So as Newton's third law, always it is applicable only when the two bodies are in contact. Like one body should apply, the action is done by the one body and the reaction is shown by the another body. Then only we can say that Newton's third law is applicable. If not, Newton's third law is not applicable. Nobody will show action and reaction. It is not possible to show in the single body. Always action need to shown by the one body and reaction need to shown by the another body. Now, the similar phenomena here also it will take after Kepler's three laws. Do all people knows Kepler's proposed how many laws to describe the motion of the planets? Yes, please. How many laws proposed? Three laws. That is only we can say what? Kepler's first law, Kepler's second law, and as well as Kepler's third law. That is what Kepler's law of what is the first law called as? Kepler's first law. Law of orbit. Second one, law of areas, and law of periods. Now, if we take after his work, after Kepler's theories in 1666, Mr. Sir Isaac Newton, 1666, around 45 years after Kepler's theories. Imagine then. So 45 years after Kepler published his work, Newton began his studies of planetary motion. Means in the year of 1666. Before 45 years itself, Kepler's proposed his work. So after that only Newton's came into the scene and he has started studying about the planetary motion. Then he found that the magnitude of the force, that is what F on a planet due to the sun, varies inversely with the square of the distance between the centers of the planet and the sun. You might be not understand, I will say you. So he has been found that whenever he knows that, as we know, without Newton, half of the physics won't be there. So what is the Newton's famous story? Anybody can tell me? What is the Newton's famous theory? Mitakshri? Divya? Gokul? What is the Newton's famous theory? Apple story. Do you remember Apple story?
Yes, sir.
Yeah. So the same way, you can see Newton law of gravitation also, after 45 years of Kepler's theories, Newton has started studying about this planetary motion, and he used to try to throw the ball up. So as we know, whenever we'll throw a ball up, it will continuously fly away, or it will be after traveling certain distance, it will be fall back again. Yes, please. It will continuously fly away, or it will be fall back again?
It will fall back again.
So when we throw a ball up, it goes a certain distance upwards and falls down again. So according to Newton's first law of motion, which we studied in the second chapter, do you remember? According to the Newton's first law of motion, what is the Newton's first law of motion? Unless the external force is applied, the body which is in state of rest remains in state of rest. The body which is in motion remains in state of? Nobody is saying what is in this. What is Newton's first law? Anybody? What is Newton's?
The body in rest stays in rest until an external force.
Mr. Hari Jairaj, you also don't know, also no problem. You can understand. Newton's first law will says that, okay, I have two bodies. Now one body is in uniform motion. One body is in uniform motion and another body is in state of rest. Now, unless external force is applied, is it possible to bring this body into rest? Respond, please. Is it possible to bring this body into rest?
No, sir.
No. Unless external force is applied, is it possible to create a motion in this body? Is it possible to create a motion in this body? Yes, please respond. No, it is not possible. Yes or no, guys? Yes or no? The same thing. Now, if I'll throw a ball in the upward direction, now the ball must be going a straight line continuously, but after traveling certain distance, it is again returns to the earth. Means in the sense of somebody is applying the external force. So who is applying the external force? Yes, please. Who is applying the external force? Who is trying to pull it down?
The earth, sir.
That is what it is. So, according to the Newton's first law of motion, that is why I can say people will think there is no interconnectivity between the chapters. So, when we throw a ball up, it goes a certain distance upwards, then again it will be fall back. If I'll throw a ball, so after traveling certain height, again that ball will start falling down. Then, as we know, a body at rest moves only when a net external force is applied on it. Same way, when a body started reverse back, then also somebody is applying the external force on it. Then only the ball, it will went up, then it is returning back. I applied the force to push it up or coming down. What the force I applied, it will to go it up or downward direction. I have thrown away. So I applied the force in what direction? I have thrown away
Upward direction.
upward direction. But if I apply the force in upward direction, why the ball is coming downward direction? Why the ball is coming downward direction? Then means in the sense of someone is pulling downwards. Is it yes or no, guys? Yes or no? So that is why the ball will come downwards after traveling certain distance. So then Newton has troubled. This question is always troubled Mr. Sir Isaac Newton when he observed an apple falling from a tree. Same thing. Why this apple is coming always towards to downward? Same way the ball is thrown upwards after reaching to certain height. The ball is also coming downwards. Why it is happening? What is the reason? Then only he concluded that. What he concluded? The earth must be exerting a force of attraction on the apple, and same way the ball which I have thrown upwards. Then only he said that whatever the body has been thrown upward direction, always it will be falls towards back to the earth because it will get accelerated towards to it. That is why he proved that this force of attraction is not confined between the earth and the other bodies of the earth. It is also existed in any two bodies anywhere in the universe. That is only it is called as force of gravitation. What is to call, guys? Force of gravitation. So this force of gravitation not only present only between objects and earth. It is present between any two bodies in the objects, any two bodies in the universe. That is why it is called as universal law of gravitation, or we can say Newton's law of universal gravitation. Anything we can say that. He has been proved that. How he has been proved? With the help of Kepler's laws and that inverse square rule. That is all we'll study in the next class. So hope you all understand what is the force of gravitation. So the pulling force, whatever the object is thrown upwards, always it is trying to get accelerated back towards to the earth. So that force of attraction only he called as what? What Newton's called, guys? Newton's called as force of what he called?
Gravitation.
Force of gravitation. That is why whenever apple fall on his head, then only he understand apple is always gets accelerated towards to whom? Towards to earth. So then he proved that with his theory, the force of attraction, that is only called as force of gravitation, is not present only objects and the earth, but is also this force is exist all the bodies, any two bodies in the universe. That is why it is say a force of gravitation, and this law is called as universal law of gravitation. Now this universal law of gravitation, how he proved, what he proved, that is all we'll study in the next class. So with the proof he has been made, so that is what we will practice in the next class, and how he derived also will study. So let it be with this. I will stop the today's class. Hope you all understand what is Kepler's third law. So what is Kepler's third law? Anybody can tell me at least one time? Kepler's third law, please. What is Kepler's third law? Just at least equation. Anyone? What
The
is
square of
The
T
square of time period is inverse, directly proportional to the
cube
cube of average radius.
radius of the planet's orbit? That's all. Okay. So this is what, that is what Kepler's third law. And if we take two planets, what is the ratios? T1 square by T2, R1 cube is equals to T2 square by R2 cube is equals to what? Is it
constant.
constant? That is what for two planets. So that is all. Please learn carefully. So then Newton's law of gravitation, tomorrow we'll derive it very neatly, and we'll also will study how he guessed the Newton's third law with the help of Kepler's laws. Means what is the interconnectivity between Kepler's laws and how that Newton guessed this universal law of gravitation with the help of Kepler's laws. That we'll study in the tomorrow's class. So thank you everybody. Bye. We'll meet in the next class.